Time now for a close-up. Every year in spring, heavy clouds of yellow dust sweep across the Japanese archipelago, causing all sorts of problems. These range from minor inconveniences, like having to do the laundry over again and washing cars more frequently, to more serious problems, like hampered visibility that can even disrupt air traffic. The scientific term for yellow dust is Aeolean dust. The thick clouds are made up of mineral dust particles that are less than 1/100th of a millimeter in size. The dust particles are generated mainly in the deserts of China and rise up into the sky, sometimes to a height of 10,000 meters. These particles are then carried by the prevailing westerly winds to as far away as Japan, some 5,000 kilometers from their source. Aeolean dust has become a major problem, especially in western Japan and along the Japan Sea coast. The amount of dust varies from year to year, but on the whole, it seems that the phenomenon is becoming more and more serious. Scientists have come to believe that it has a major impact on global warming, and now a joint Sino-Japanese project has been set up to throw light on the mechanism of Aeolean dust. If the dust particles absorb sunlight, this will result in further global warming. But if they reflect sunlight, then the global temperature will fall. The impact Aeolean dust has on global warming depends on its properties and amount, but so far very little has been revealed. In this edition of Close Up, we'll be focusing on the latest in Aeolean dust research.
The Taklamakan is the largest desert in Asia, extending over an area of about 330,000 square kilometers. It's believed to be one of the main sources of Aeolean dust. 3 years ago, 80 scientists from Japan and China formed a joint project team to throw light on the mechanism of Aeolean dust and set up an observation point in the desert. The AJEC project, which is short for Aeolean Dust Experiment on Climate Impact, has involved surveys that include measuring the amount of dust supplied to the atmosphere and its particles. The project team is headed by Masao Mikami, who is a senior researcher at the Japan Meteorological Research Institute. His main concern at the moment is to take accurate measurements of the amount of Aeolean dust that is generated by this vast desert. This will enable researchers to gain a deeper understanding of global warming. Mr. Mikami has this to say about his concern.
ここからね、それどれだけ黄砂と言われているものが
We hope to eventually find out the exact amount of Aeolean dust that is supplied to the atmosphere and transported by winds.
Since this calls for the utmost precision, various kinds of high-tech sensors have been set up to conduct round-the-clock surveys. So scientists are also collecting and analyzing sand samples to discover the properties of Aeolean dust. A sandstorm struck the observation post on the day surveys began this year. It offered scientists an ideal opportunity to study the mechanism of Aeolean dust up close. Mr. Mikami pointed to the cloud of dust hovering over the desert.
あそこに白く煙がこうあるように見えますけども、黄砂の
See over there? It looks as if smoke is rising from the surface. You're witnessing the making of Aeolean dust. That's its source.
Mr. Mikami and his colleagues are trying to throw light on how the dust particles are generated into the atmosphere. But that's easier said than done. Aeolean dust is comprised of minute sand particles that are less than 1/100th of a millimeter in diameter. Such particles normally tend to stick together and therefore cannot be ejected into the air. In theory, they would not be lifted from the ground even by a relatively strong wind. So what causes Aeolean dust? Mr. Mikami and his group decided to focus on the movement of the sand particles. During a sandstorm, when the wind velocity reaches a certain speed, some sand particles are sent into a horizontal motion as if they are tracing the surface. These particles then strike the surface. This shock breaks the connection between the particles on the ground, which are in turn lifted up into the air. In this way, countless numbers of minute particles are generated into the atmosphere and transported by strong westerly winds to form Aeolean dust. This is the conclusion drawn by Mr. Mikami's research team. 3 years after launching their studies in the desert, they finally confirmed that when the wind velocity reaches a speed of over 8 meters per second, It causes a universal momentum in the fan particles, resulting in the generation of Aeolean dust.
砂が舞い上がるという単純なことにしても、全体の仕組みの7割ぐらいがようやく分かってきたかなという。
It may seem like a simple process, but we've only managed to discover 70% of its mechanism. There's so much to learn about nature. It's so complex.
The scientists are also doing research to understand why Aeolean dust can be transported as far as Japan and other parts of East Asia. A joint Sino-Japanese project team set up observation points in Dunhuang and 9 other places to monitor the movement of Aeolean dust in the atmosphere using laser beams. This makes it possible for them to monitor the movement of Aeolean dust at heights of up to 10,000 meters above the surface. The scientists keep a detailed log of the amount of dust being transported at specific heights. The collected data is used as a basis for gaining an understanding of the overall movement of Aeolean dust.
This research is headed by Masaru Chiba, head of the Japan Meteorological Research Institute's Environmental Meteorology Department. Mr. Chiba and his team are trying to pinpoint where Aeolean dust is generated and analyze the movement of the minute dust particles in the atmosphere by inputting the observation data and satellite information on the weather and ground surface conditions into a computer. Previous research has confirmed that the spread of Aeolean dust depends very much on its source. The dust from the Taklamakan is blocked by soaring mountains, and because of this, the majority is scattered across the center of the Asian continent. On the other hand, the dust from the Gobi Desert is transported to regions far beyond, not only to Japan, but sometimes as far as the Pacific Ocean. Recent discoveries indicate that there's a strong possibility that the dust is generated at sources farther west than those known at present. On March 26th, a thin cloud of Aeolean dust appeared over Hiroshima, Matsuyama, and other areas of western Japan. China is thought to be the main source of Aeolean dust, but this year China experienced unusually heavy snowfalls, so there were hardly any large sandstorms.
Where then did the dust come from? Mr. Chiba's team decided to simulate the movement of the dust using computer analysis. The results showed that a sandstorm occurred near the Arabian Peninsula around March 19th. The resulting Aeolean dust was slowly carried over Mongolia, and 7 days later it arrived in Japan. Mr. Chiba suspects that it's highly likely that the origin of the dust is actually somewhere in the Middle East.
日本で観測される黄砂というのはほとんどが中国。
It was previously thought that most of the Aeolean dust observed in Japan originated in China, but it appears as if the problem is no longer regional. We need to think in terms of observing the movement of Aeolean dust on a global scale.
Observations have been expanded to cover not only the Gobi Desert and the Taklamakan Desert, but the Arabian Peninsula as well. So it's now possible to pinpoint fairly accurately when and how the Aeolean dust from each of these regions is carried. More about this from the president of the Desert Academy and a member of the joint Sino-Japanese project, Masatoshi Yoshino. He's a meteorologist and a professor emeritus at the University of Tsukuba.
だいたい高いところを回っている黄砂と、それから低いところを。
Aeolean dust can actually be divided into 2 categories according to the altitude at which it travels. The dust that travels at high altitudes is transported globally. The dust observed in Japan comes not only from the deserts of Asia, but from the Sahara and even the United States. Minute particles from these arid regions are circulating at a height of around 10,000 meters. The heavier particles do not travel that far and fall near their source. So the dust from the Taklamakan Desert falls mainly in China. The dust originating in eastern China, however, crosses the Korean peninsula and falls in Japan. So the movement of Aeolean dust is really on a global scale.
One of the countries suffering from Aeolean dust is South Korea. The problem seems to be getting worse every year, prompting studies on the effects of Aeolean dust may have on health issues.
South Korea is located near the source of Aeolean dust. It's not uncommon for it to have over twice the amount of dust that falls on Japan. In March last year, a massive cloud of dust struck Seoul, reducing visibility to such a degree that it was difficult to see a building a kilometer away. The frequency with which these clouds are spotted has made people increasingly apprehensive about the adverse effects on health. Some supermarkets have organized special sales counters featuring all sorts of goods to keep out dust. What do the customers think of Aeolean dust?
A woman replied, "I make my children wear masks, and I always carry around a cover for the baby stroller."
A man says, "Who knows what's in the dust? It really worries me to the point that I avoid going out as much as possible."
Responding to the growing concern of the people, the South Korean government in April set up a special project team within the Meteorological Agency. Its members include experts on meteorology and yellow dust. From mid-February to May, the members of the Aeolean Dust Countermeasures Group make predictions on when and which parts of the country are likely to be hit by Aeolean dust and the density of the dust clouds. Their forecasts are based on satellite images and weather charts. When a heavy cloud is forecast, a warning or alert is issued, and during this period, elderly people and children are forbidden to go outdoors. Let's hear from Mr. Chung Yong-sing, one of the members of the Meteorological Agency's Meteorological Applications Department.
Mr. Chung said, "Aeolian dust spreads over vast regions. It's not limited to a certain area. It's the government's responsibility to provide the people with forecasts. Such information is vital."
Meanwhile, studies on the adverse effects of health are also being conducted. Dr. Im Young works at a hospital in Seoul. For the past 20 years, he's been treating people suffering from pneumoconiosis, a common ailment among coal mine workers. During the course of treatment, he came to realize that the condition of some of his patients worsened when there was an onslaught of Aeolian dust. He began to suspect that the dust has adverse effects on the lungs.
Dr. In said, "Aeolian dust is comprised of minute mineral particles, just like the dust that affects the lungs of mine workers. Unless we conduct comprehensive research on the effects of dust, including Aeolian dust, we won't be able to find out what causes the deterioration in the condition of patients suffering from pneumoconiosis. This is what prompted me to look into the problem."
Dr. Im is now experimenting on rats to gather basic data on what sort of effect Aeolian dust has on the lungs. At what level of density does the dust become a health problem? Finally, let's consider the significance of the joint Sino-Japanese research that was launched 3 years ago. Here are the views of Masatoshi Yoshino, Professor Emeritus at the University of Tsukuba.
黄砂というのはですね、ダストストームで舞い上がりますね。それが運ばれて
Aeolian dust is lifted up from the surface in the form of a dust storm. These storms are becoming more and more frequent because of global warming. Aeolian dust is both the result and cause of this meteorological phenomenon, and that's why it's so important to find out more about it.
The research on Aeolian dust is likely to have a major impact on both our lives and the global environment. And that's it for this edition of Close